Hey everybody, today I will do another math problem. And today we will work on which is called the definition of derivative. Um, we will do one example and we will kind of work through how that the definition of the derivative, if you know, is how it was derived. Actually, I just we'll just cover the basics, all right? How the definition of derivative actually can be used to find the slope of, or to find the derivative of a function, right? Because a lot of times the teacher will say, okay, find the derivative of this function using the definition of the derivative. And I think it's a very important topic to cover. And so here I will do some type of function, for example, something like that, right? So, and I will say that I have 2 points. I got point right? So I have 2 points, right? And I have what is called a secant line, right? This is a function f of x, right? So, and I got a line that crosses these 2 points, right? Something like that, right? And we can call these points here where the line is crossing, we can call P, we can call that Q, right? Q. Now, and on those points I will pick up another point, not a point, but a kind of interval on the x-axis. Let me put the P here, right? And let me put, actually, let me do this in black, right? So, this is P, this is Q, and here I got an A, right? And here, actually move that Q up. This is Q here. I wanted to keep it in black. So this is point Q, and here is P, right? So, okay. So now, here, I'm going to drop another little line, and I call this A plus H. Right? So, I call this A plus H. Right? And then I make something like that, right? And I call that distance H. Okay, so so here I am calling this distance H because notice that, let me just make this, if I can make it better. Nah, I mean it's okay. Okay, I call this distance H, right? And this point here, look, if you see, you got a plus an increment, right? So a plus an increment, but if you look at this, if h approaches 0, right, go in this direction, that means that h is getting smaller, right? So we will see that in a minute, right? Okay, so this is the second line, and then I am getting this second line closer and closer and closer. See, at this point I'm still getting a second line. See, the second line crosses the curve in two locations, right? So this line is crossing, this second line is crossing this point here, and at this point here, this line, this curve is being crossed by this second line, right? And that is the difference between the second line and the tangent line, right? Now I can make another second line, right? Then the next one is going to be touching, and that is called tangent line. Tangent line. Right? This right here is called the secant line, right? So that my graph doesn't look like the book because I didn't copy directly from the book. I did my own graph. But yes, so that is called the secant line through point P and Q. I did mine different, but that is okay, the same idea, okay? So you notice that these lines are getting closer and closer and closer to the tangent line, and then the tangent line is called the slope. That is what's called the derivative. When I call it, you can actually see that it might cross right there at that point. The tangent line only crosses at one point when it touches the curve. Secant line usually touches in 2 points. You can see here, touches in 2 points, right? And the tangent line only touches at 1 point, right? Now, what is the whole thing actually? You know, all right? So the formula for this is the following. The formula is F you can call it MQ, right? Because it's because it's between P and Q, so you can call it MPQ equal to A plus H minus F of A over H. And that is the formula for this tangent line, right? For the tangent line, right? Which is basically the slope, right? That's why we call it M, right? Now, let's do an example using this. So let's do this quick example. Let's do let's do f of x equal 3x squared minus 12x minus 8. And let's use this definition of the derivative. It is called, matter of fact, this is called the definition of the derivative. The definition of the derivative, and usually we say that h approaches 0, right? Okay, so let's use that formula to do this problem, okay? Notice that I have an a plus h, right? In this case, what I'm going to do is I want to replace a by h by x, no, x by a by x. So a is equal to x. Now, what I'm going to do is the following. So I'm going to go ahead and just put a bracket here. I put 3 here and put a set of brackets, right? And then in this bracket, I will replace whatever I see at x So let me just kind of go through this real quick. You can see as h approaches to the left, approaching a, right? The tangent line is getting closer. See? If h approaches a, the tangent line, I can actually do another triangle here, and it's getting closer. Another triangle here, and it's getting closer. And then, see how it's approaching, right? So basically A is approaching A, right? And the triangle is getting closer. It's getting closer and closer to A, right? The triangle is getting smaller and smaller and smaller and smaller, right? So, see that? Okay, so using that definition, we can do this, right? So everywhere where I see an x, I want to replace by this, right? A plus h. But at the same time, I am just doing, because a equal x, I can just say x plus h, right? A square. Actually, I think the best way to do it will be like this. Okay? Then minus 12 x plus h, right? Minus 8. So here I can put another set of brackets. Minus the function, right? Minus the function at a, which is x, right? So in this case, will be just a function, right? So 3x squared minus 12x minus 8. Okay? So let's do this part here. So let's do this. So let's do 3, right? And then x plus h times x plus h minus, actually I can distribute this part here, right? And I can get 12x minus 12h minus 8 right? And then here I can just bring that 3x squared minus 12x minus, sorry, plus 8 minus 8, right? But notice that here, if I distribute that, that means I got to distribute the sign across. That becomes positive 8, right? Now, before I do anything, any canceling, I want to make it sure that I put that over the entire thing over h. Now, this here also goes over h, right? Now I'm going to go ahead and distribute this part, and I get 3, right? Alright? So actually, you know what? Let me put that inside the bracket. So, right? So I want to go ahead and distribute this part, right? And kind of get rid of the brackets, right? So I get x squared, this times this, plus hx, right? This times this, and then hx plus hx, right? This times this is equal, this times this is h squared, right? Then I can put something like that, right? And then I got 12x minus 12 minus 12h minus 12h plus 8 plus, minus 3x squared minus 12x minus 8. Everything over h, right? Notice that now I can distribute that guy, that 3, and I get 3x squared, and I actually, and add this to, right? This equal, this right here is 2hx, right? Okay? So when I distribute that, that becomes 6. When I multiply this times this is equal to, because I already added this 2, right? So it's equal to 6hx plus h squared minus 12x minus 12h, right? Actually, before I do, because I'm going to just kind of repeating thing here, right? So now that I have it this, right, I already distribute this part, I can do some canceling here. I can do some canceling. And okay, so okay, now see this. This you gotta be careful here. This one you got be extremely careful. Careful. See? Here, because initially no, it's fine. It's fine. Okay, let's see. this is minus, right? So minus f of a. Okay, so this whole thing back here, this whole thing back here, all right? So when I do that, that's why it's important to put a bracket. See, when you put bracket here, that becomes a plus, right? And this becomes a plus. And this becomes a plus, right? But I leave this alone. I don't have to do anything with this. This actually, I'm sorry, that bracket is only to serve me that it is part of that, right? Yeah, so not even bother putting bracket now because that creates kind of confusion. So here, this becomes a negative. It's a negative. It's a negative, right? And this here is a positive, and this here stays a negative, right? Now I am ready to do some canceling here. So I can cancel this and this, right? I can cancel this and this, right? And then I am left with what? I am left with this, which is 12, which is 12H. So it's 12H, right? So it's 12H and then minus 3x squared all over H, right? So now I can do some more canceling here, right? So now I can cancel this. I can cancel that, right? I can add those two, this equal, and then what I can do is just basically reduce this to what? 6ax plus h squared minus 12, right? Minus 12 yes, minus 12h, right, over h. Now I can factor out h out, right? When I factor out h, I get what? I get 6, h comes out, I get 6x, and I get h minus 12 over h. Now this and this cancels out, right? And I am left with what? I'm going to go bring to this to this board here. I am left with 6x plus h minus 12, right? Now remember that the limit here, h go to 0, forgot to mention that, h go to 0, h approaches 0, I just say h approaches 0, when h with the limit, it's called limit limit of h approaches 0, limit of h approaches 0, then what I can do here is the following. Limit h go to 0 or approaches 0, then I can say that 6x plus 0 minus 12, right? So 6x minus 12 so the slope of the line is, which you can say that you can call it f prime, you can call it I don't know what they call the books call it, but you can say that the slope of the line m, or whatever the tangent line, right? You can call it that the slope of the line or the derivative is called you call it f prime. F prime of x is equal to 6x minus 12. F prime is the derivative. That's what it is. F prime is the derivative. And eventually, probably I will explain a little quick why is it called f prime and why is another notation is called dy dx is the same thing, right? So that is the slope. This is the slope of this function using the definition of the derivative. I hope this helped anybody who was taking basic calculus. I hope this helped, and thank you for watching. And don't forget, if you like the videos in this channel, don't forget to subscribe and give me a thumbs up. Thank you for watching.